Yeah, okay. Hello, my name is Simon. I'm a cybersecurity engineer and active cybersecurity practitioner. I do a lot of research when it comes to cybersecurity and networking. So today I want us to look at a tool. Uh, I've decided that any free time I'll be getting, I'll be going through one of those basic or those beginner tools in Kali Linux. So the tool we are looking at today is Wireshark, and Wireshark is a packet analyzer. And this video might be a very long video. We'll be looking at Wireshark in depth. So I'll start. Since Wireshark is not installed on my machine, I'll just open the terminal. So I have a PDF file that will be guiding us through this uh, Wireshark tool, and it has some information about what Wireshark is. Actually, Wireshark is an open source tool. It's also available on Windows, yeah, but I prefer using Kali Linux, so I use it on Kali Linux, but it's also available for Windows and not sure about Mac, but probably it is available for Mac also. Macintosh does the Apple computers. And this is the purpose. It captures and analyzes network traffic in real time, helping in troubleshooting, security analysis, and network optimization. Key features is it has a deep inspection of hundreds of protocols, live traffic capture, and offline analysis. This is where you save. Offline analysis is where you save that file. It's saved in form. It's in form of a P. Is it a PKT? You save a file that you will analyze later. You record that traffic, you save it, and you'll be able to analyze it later. It has its advantages. You'll come to see about that. It has ability to decrypt many protocols, including SSL and TLS. The protocols IP, TCP. We'll look at them. And the reasons to use Wireshark are many. Have network troubleshooting, have security analysis, protocol development, and real-time monitoring. Something that people in the SOC do. Yeah. So it has filters, and these filters will classify them into different categories. This just narrowing down to the specific thing you want or the specific protocol you are looking at, depending on what you're monitoring or what you're exactly looking at. So I see our video is already 2 minutes. So what I will do, I'll open my terminal, then I'll type Wireshark. Wireshark, it's not pre-installed. You can see it's now prompting us to install. I'll press Y for yes, and then I'll enter my password. Every every time. Okay. I'll install it. It's not a very big tool, so it's supposed to install in the shortest time possible. And yes, I have a Wireshark now installed on our machine. So what we do, I'll just go directly. We'll be using that folder. I don't know, that PDF file as our guide to what we are learning today. So I'll do this, then I'll type Wireshark. Wireshark, you can see now it's available. It has a shark fin and a blue background with a black highlight of the fin. And we've opened Wireshark. We are into Wireshark. So this is a packet capture tool, and you can see the many traffics we have. WLAN O, which is Wi-Fi, any Bluetooth loop back is 0. We have so many, and what I will do, I'll just narrow down to the WLAN O, which is the Wi-Fi. Then open it, because okay, whatever I'm connected to, I have permission to access all these details or access it. It's something I've set up for the purpose of what we are doing. So I'm not going against anyone or any organization to bring this video to what we are doing. So these are packets, and you can see have several things about Wireshark. So this is the menu. It's the general menu you get to see from different systems. So I talked of saving a file and analyzing it later. So what we are doing is we are capturing, and okay, I'll come back to that, whereby you can just export that file. I guess it's the PKT. It's been a while me using this tool. Yeah, but you export it, you go analyze it later, and you understand. For instance, is maybe you've received a report that something happened at this time, so you get out that file, you go analyze it, and after analyzing the file, you can be able to come up with a conclusion or a report. And we'll be using our guiding PDF. So what we'll do, we talked of filters, and filters is just to narrow down on the specific thing you want to access. How does it? So this is the next page. How does the threat work? Attackers generate a high volume of HTTP GET requests, overloading the server's capacity, causing the denial of service. Denial of service is whereby I overwhelm a system by giving it many requests that the requests it can hold at a moment, so rendering it inaccessible to get other requests and also disrupting the requests that were in the process. So that's what happened. And the display filter for GET is this. So in an instance, whatever I'm connected to, let me copy this filter, control copy. For instance, whatever I'm connected to receives a heavy request or a heavy DDoS request, this is what will happen. And actually I can simulate that because I have a system I created from an ESP32 that can be able to flood a Wi-Fi network with many requests. So it's something I can simulate, but for the purpose of this video, let's just move fast, go through it, then I'll narrow down going specific bit by bit later when I'll be now expounding on this. So this is the method, it's get method. I'll come back to our Wireshark. So here is where we apply the filter. So because these protocols are many, you want to specify that maybe you want to see the TCP, HTTP, or whatever protocol we are looking at. So I'll come here, then I'll apply that filter. So the method is get, okay, it's HTTP, request method is get. So I narrow down to how many get requests are being pushed onto this network, and you can see that for instance the network you're using, they'll get request at this point. After applying the filter, you can clearly see there's none. But if I were to open that system and push those requests or push that DDoS attack, what will have happened is that the system will publish so many of them, spawning at each second, many. And this just follow this PDF guide. How to detect? Just open Wireshark, navigate to the filter bar and enter the above mentioned display filter. Check the HTTP headers for any abnormal number of requests from the same source IP. So what happens is this DDoS, when a DDoS is performed, it replicates that IP many times. So request is coming from one point with the same IP, but it's coming many times. So those are one of the things you can use to know that it's a DDoS attack. Oh, one of my lights just went off, but it's okay. We now look at the DNS tunneling. How does the threat work? DNS queries are manipulated to transmit data by passing files and performing covert data exfiltration, and the filter is DNS. And how to detect? You just open Wireshark, navigate to the filter bar and put the above filter. For this filter is just DNS. Then I control copy DNS, and let's go here, and at the filter bar you just control V, and you can see there are many DNS requests here, and one of them is on the Mozilla Firefox. It's Mozilla, and I don't know where it's coming from. Yeah, but probably to some other system connected. You can see this. Here is Snapchat, and you can see chatgpt.com, and you can see ChatGPT. Somebody is using ChatGPT, somebody is using Snapchat. They are not as many, they are very few. And I'll just go directly to these other. So we have SMB brute force. How it works: multiple login attempts are made via the SMB protocol, trying to guess valid credentials through repetitive trials. So this is it. If I open the system and I put in this, but this won't display anything. because nobody is trying to do that assembly brute force. But for the purpose of learning or understanding what we are doing on this video, let me just put it into the filter bracket and see what spawns out. You can see that nothing spawned out because that attack was not, or that brute force attack was not on. But for instance, I think I'll have to redo this video in a different way so that in each instance I'll be performing it so that you can be able to see what happens and exactly what comes out or what plays out when that attack is simulated. See, that is not open. We have the SYN flood attack, and how it works: attackers flood the target server with SYN packets without completing the TCP handshake, exhausting the server resources. So we have let me just open it on Wireshark. It's called a handshake, and also this happens when you're trying to this happens when okay, uh, it happens when you're trying to hack into a Wi-Fi network. What happens is you first create that request, it's acknowledged, and after the acknowledgement, it's now that you can be able to communicate. That's what's called it's called a three-way handshake. And you can see this one, there's A and C, means it has been acknowledged, A and C and C. I want to see the SYN, with the SYN. You can see here, SYN, SYN. So SYN, SCK, it means this went through, all these complete handshake, the communication went through. And yeah, that's what we are talking about when we are talking of the SYN flood attack. So you flood, you send packets without completing the TCP handshake. So it means that you are initiating a conversation. It's like an example is you're initiating a conversation, but anytime this person is trying to respond, you're initiating another conversation onto another conversation. So you're exhausting them to a point that they are confused which conversation to respond to. And that's the same thing that probably happens, or that's the explanation to what happens when there's an SYN flood attack. And how to detect it is navigate to the filter bar and enter the above mentioned. Okay, let's enter this. We might be able to see this. Maybe if somebody is trying to access a resource and it's not being delivered, or the website is down, and I think one of the websites I was using is down, so maybe you can be able to simulate it in real time. Yeah, you can see there's something of that sort happening here, and yeah, I knew there's something of this sort that happened. So let's just come to understand the context. Open Wireshark review the TCP headers and check if there is a high volume of SYN packets without corresponding SCKs. If there are some SCK responses, look for unusual delayed SCKs or connection resets. And yeah, we'll just look at that. So these put the SYN, there's no SCK, SYN, SCK, SYN, no SCK, no acknowledgement. It means the handshake was not complete, and these are an example of what we're talking about. The protocol is TCP, is the transfer control protocol, and we have the source and the destination, but there was no acknowledgement here, and at least that one gave us and we go to the next one. So we have the DNS amplification. So first of all, I got this video from LinkedIn, one of those cybersecurity engineers. It posted it, and it promised to simplify the understanding of Wireshark. So we have this DNS amplification. How does the threat work? Attackers use small requests to trigger a large DNS response, reflecting traffic back to the target and overwhelming it. I have ICMP flooding, ping of there. It's called ping of there. How the threat works: the attacker sends numerous ICMP requests, pings to overload a device, consuming bandwidth and resources. So what happens is, if your internet has an issue, you are connected. Let me put it here. Let me just ping. Let me ping. Okay, let me ping one of my routers. We've sent, and you can see here we've sent some data. Actually, it will also be able to display on Wireshark. Just open my Wireshark. Let me clear that one. It should display somewhere here. There are so many requests. Okay, yeah, you can see that something is happening, and it's something repetitive. You can see it's repetitive, and you see it's ICMP. We've pinged something. You can see all some most of these requests are ICMP. There's what happens with the ping request, and you can see as many as they are on this side. On the other side, there are also as many as this side. So I have to stop it. 58 packets transmitted, 0% loss. You can see that I've already been able to test and know that this network is clearly or it's working well. I can ping that server. So what happens is with an attacker, they bring up those requests. They, like let me say they overload the request. They bring up many requests as the one that can be held. So it overloads the device because you're trying to send packets and you can only know that the communication is complete while packets can be received on the other end. It means the other end also has to respond or also has to receive. So if you overload it with many requests or many of those packets, it will overload the system, and the system, it will consume the bandwidth and the resources. So it will overload the device. And how to detect them is open Wireshark, enter the ICMP protocol. So equally, what we could have done is just type the ICMP, and you can see all those many requests that were being run. There are so many. You know what? Okay, can see that's what happened. And we have ARP spoofing. An attacker sends falsified ARP messages leading devices to link wrong MAC addresses with the IP addresses. And how this is detected: open Wireshark, navigate to the filter, you enter that one. Inspect the ARP headers for the mismatches between IP and MAC addresses. I don't think this will be visible. I really don't think that will be visible. Yeah, that won't be visible. Uh, the DNS poisoning. DNS responses are altered or forged to redirect users to malicious websites instead of what legitimate ones. Let me just control copy. I think this one will also not be visible because there's nothing of that sort going on here. But what happens is that what happens with the DNS. First, what is the DNS? Let's just type in the DNS before I explain it. So, is the domain name system is a phone book of the internet connecting browsers with websites. So what the DNS really does, it translates websites stored as IP addresses. So it translates that, or it maps that domain name onto an IP address, so that when you search google.com, it gives you the address to google.com and redirects you to google.com. And that's what the DNS does. So if I alter the DNS, I'll be able to redirect you to a different page. And of suspicious HTTP, the several these pages it's getting low. And what I think I'll be doing in the next video is what I'll be taking a specific thing. I'll be going in depth with it. Though also I think that we'll be making a very long video, very many series of these. But that's just the beginner part of Wireshark. So it's an open source tool. It's available. You can run through it and see what happens with it. Yeah, that's all I can say for now. Oh, so this is what I was talking to. You can export these here. Is it export? You can export it as one of these. You can export also here.